Hello everyone, we are group 5. My name is Mayo Fukuda and I will be talking about our final project, predicting rental price trends in different regions using RNNs. So here is our agenda of this presentation. So first, I will be discussing the real-world problem international students faced regarding of housing. Then I will talk about data we use for this project. And I will go through the steps we took to do the data preparation. And Jasmine is going to be talking about models and its model performance and conclusion. So our final project aims to tackle a real-world problem faced by international students, which is lack of reliable rental price prediction when choosing housing and planning their budgets. And as myself, international student, I had this issue before coming to USF. Because of the geographic barrier, it was very difficult for me to find accurate information on housing in timely manner. I did not know anyone in Florida at that time, so it was very hard for me. And I remember I was frustrated and concerned about where to live around USF and how much money I will require for living. The importance of solving this problem is that it directly has an impact on students' quality of life and budget management. And in this project, we will attempt to predict the housing rental price by using deep learning models, specifically RNNs. And in this slide, I will be talking about the dataset we used. So the dataset we used is taken from the website called Zillow, and it consists of rental prices from 2015 to 2024 on a monthly basis, comprising 111 time series values for each geographic area in the United States. Additionally, there are 9 geographic related features, such as region name, states, and counties, etc. And in total, there are 6,993 rows and 120 columns in this dataset. And these are the steps we took for data preparation. So first, we dropped the time series values before 2023 as our project focused on predicting the value of 2024 based on 2023 data. Then we removed irrelevant columns such as region ID, size rank, region name, region type, state name, state, and metro. And after that, we identified how many null values in each columns in the dataset. We got some null values, so we decided to drop the rows had null values. Since we are using 2 categorical features such as city and county name for our project, we performed one-hot encoding to convert categorical values to numeric values, which is suitable for model training. And the reason we chose one-hot encoding is these data are nominal, where there's no order among categories. And after that, we used a standard scaler to standardize the time series values to ensure uniformity in scale. And now we have the standardized values, and values are ranging between -1 to 1. And lastly, on train and test split. So we allocated the standard train test split ratio, 70% of data to training and 30% to testing. And the random split can be done as each observation is independent to the others in our case. Now, Jasmine is going to be talking about 3 models that we've used and the results.
And when we finish the data preparation, we will use those data to fit in our models. And here, we use 3 different models to train our data. The first one, we will use 3-level RNN with 1-level SLP. The second one, we use 3-level LSTM and the 1-level SLP. And the third model, we use 1-level GRE with 1-level SLP. We are not only use the model for RNN for time series value, such as RNN, LSTM, and the GRU. We also use another layer called SLP, which is a single layer perceptron, to train the model for the non-time series features. So now we can transfer to our code to see how we did for those models. Okay. So here is the code for our data sets, how we did for our data set and how we trained those models. First, we will load the data and clean the data sets. So here is load the data, and we check if there are any columns we don't need it. And at first, because we only need to keep the value in after 2023, so we will remove the columns before 2023. And after that, we want to drop some columns we don't need it. So here we drop those columns, and after that we check if there are any missing value in this data set, and we can see here there are many value is missing in this data set, so we try to deal with those data. And at first, we want to use the mean score for the missing value, but we found that the test result would not be good for that. So we just remove those missing value, and the test result would be better. So we remove those items. And as we mentioned that our feature is the categorical item, so we use one-hot encoder to transform those values. So we transform the value for city and county. And here is the data set we transform. We did the transform. And here we can see there is more than 2,000 columns we have in this data set right now. And after that, we use the standardized to do the standardization for our rental price. And after we did those parts, we use the train and test split for our data sets. And because we will use the time series model and also SLP models in our models, so we split the data for the static and the sequential data for training model. And because the RNN need to use 3 dimension, so here we just reshape the data for 3 dimension. And after we finish the data preparation, now we are input those data on in our models. First is 3-level RNN and the 1-level SLP models. And we just input our data in this model, and we train it like 10 times, and we got the mean square error as the 0.014. And we want to look more evaluation for this models, and we use the R-squared score to check. It shows the 0.97 is 97% for R square values. And we use the plot to see our prediction and the actual price. And we can see it's very close for the predict and actual rental price for this model. And then we use the we changed the RN to LSTM for the second model. And then we just input our data in this model, and we found that at the MSE is increased to 0.044, and the R square also decreased to the 0.92, which means it's the result is not good as the first one. So when we use the plot, we can see the score, the predict and actual value looks close, but it's a little bit large gap than the first one. And then we use the third models to train the data. Is the one level GRU and the one level SLP model. We tried to use the 3-level GRU before, but the result is really similar like the 1-level GRU, so we just keep the 1-level GRU here. And we trained this model, and we found out that the mean square error is increased to 0.34, and the R square score is really low. It's only like 43%. So it's the worst models among those 3 models. So when we use the plot to see the results, we can see there are the largest gap between the actual and predict value here. So we go back to our point. So here is the result for the 3 values. We can see the model 1 is the best results for the mean square error and the R squared. So here is our conclusion. Based on the result from the previous page, we found that the model 1 is the best model for predict the rental price because it has the lowest MSE score and the highest R square scores. And since the model 1 is the best choice to predict the rental price, so it's really helpful. It's really helpful for the international student to navigate the house option in the United States, and also our model can help them to reduce the financial concern and facilitate the informed decision making. At the end, we believe our model can help the international student have the better experience to search the rental house in the United States when they study abroad. That's all of our presentations, and thank you for your listening.